Hey there, ladies and gentlemen. So something new I'm going to try on this particular video and maybe future videos as well is I'm not going to fill in the questions on the left. I'm going to leave that to you. I'll talk through the questions. I'll talk about the notes. But I want you to start putting some thought into what kind of questions the notes are actually asking. And at the end, I might reveal kind of what's going on. But as of right now, like I said, I don't want to actually reveal the questions right away. I want you to fill those in. I think you can. I don't think it's going to be a big issue for you. But let's go ahead and talk about conditional statements. So something you need to know right at the bat about conditional statements in terms of the terminology is just this term conditional. And conditional is kind of a funny word because it's based on the word, of course, condition, meaning that one thing doesn't happen without the other thing happening. So like if let's just think about a situation like when I was growing up. Let's say I wanted to go and play football with my friends. Well, my mom might say something along the lines of, "Well, you can play on the condition that you do the dishes first," which basically means that I could play football. That event would be triggered if I could meet the condition of doing the dishes. So that's kind of what conditional means for us too. It means one event is triggered by another. In other words, B doesn't happen without A happening first. Something else we might need to kind of talk about is the term hypothesis. And hypothesis, and I'm talking more purely in the language arts sense, is definitely just a statement of intent. Okay? So I know hypothesis is like an educated guess in the science world, but the way we're using the word language arts uses it, it's more just a statement we're making. Like this is what is happening. Following that up, we have this term conclusion. And the conclusion is the logical result of an event. Okay? So kind of in the sense that if I say, well, now you read this passage, what do you conclude is going to happen to the main character? Well, the conclusion you come up with, the thing you come up with, the statement you come up with, is going to be the result of all the stuff you've read up to that point. So that's why I call it a logical result of an event or series of events happening. Let's go ahead and break that. Let's talk about what a conditional statement actually is, and then we can talk about its variance. So when we talk about a conditional statement, another way to say that, or another very common way to say that, is an if-then statement. And we call it an if-then statement because that is a typical structure. So an example might be something along the lines, and I think we use some pretty kind of random examples in class. I'm going to use a more mathematical one. So let's say if x is equal to 4, then x plus 2 is equal to 6. So again, we're seeing that if-then language. So the way to interpret this is that if we want x plus 2 to equal 6, then x has to equal 4. In other words, this is a part that we call our hypothesis. And this is the section which we refer to our conclusion. So if we want our conclusion to happen, again, if we want the logical result of x plus 2 equaling 6, we have to first meet the condition, or the burden, of x being 4. And this one turns out to be very true, simply because if you want x plus 2 to equal 6, then x has to equal 4. And that's all there really is to a conditional statement. So we have to meet the hypothesis as our assumption, and then we have to test the conclusion. So it's important to note that the hypothesis is assumed to be true, And then the conclusion is what we're going to precisely test. Or test to prove, to be more precise. And you guys caught a glimpse in class yesterday, or today, depending on when you're watching it, or a couple days ago, or a week ago, depending on when you're watching this, of what a formal proof is actually going to demand. It's no different than a story chained together by these conditional statements. So we do have some variants on a conditional statement, or on conditional statements, period. It is important to note that not every conditional statement turns out to be true, but there are some interesting variations. So one variation of a conditional statement that's important for us to know is what we call the converse of a statement. And the converse is just a hypothesis and the conclusion switched around. Okay? And again, we're not testing for truth here at all. We're just kind of examining what it means to be a conditional statement and its variants and what the structures are. So if I take the statement I had above, that was if x equals 4, then x plus 2 equals 6. Then we can certainly say in the converse sense that if x plus 2 is equal to 6, then x equals 4. Again, I literally took what was a hypothesis and put it as a conclusion, and what was a conclusion and put it as a hypothesis. So in terms of a conditional statement, even though these have been switched around, I'm still assuming that this is true. And then I now have to test the x plus 4 part, which is ultimately the difference between a conditional statement and its converse. They do come in a pair, so you can't have a converse without having a conditional statement. And the difference is what we're assuming to be true and then what we're actually having to prove. So in the converse of the original statement, I have to assume x plus 2 equals 6. Like, that is a true statement, that exists, I can't question it. So what I'm actually testing is the second part of it, which is x equals 4. Another interesting variant is a statement's inverse. Okay. And the statement's inverse is a negation of the original statement. So again, if we're taking the original statement, and again I'm talking about the original statement as a conditional statement up there in purple, the one above the yellow line, it was if x equals 4, then x plus 2 is equal to 6. So the inverse would be if x does not equal 4, then x plus 2 cannot equal 6. And that's what that slash equal sign means. It means cannot. In terms of what's a hypothesis, what's the conclusion? We still have this to be the hypothesis, which is what we're assuming to be true. And then we have this as our conclusion, which we're going to test to prove. Okay. Or could say test or prove, depending on the situation. Again, we're not evaluating truth here, even though all these turn out to be true. If x does not equal 4, then x plus 2 cannot equal 6. But we're just looking for the structure. The last structure, which is by far the weirdest, but one that you'll probably be tested over. Okay. Is something called the contrapositive. So the contrapositive is an interesting beast because it's actually a combination of the converse and the inverse. So if I take a statement and I converse it, and I invert it, I have the contrapositive. So in other words, we're going to switch things around, and we're going to make it negative. So keeping in, again, the original conditional statement, I'm going to switch the converse, or the conclusion, the hypothesis, and then I'm going to actually make them negative. So I'm just going to basically combine green and black. So here it goes. If x plus 2 does not equal 6, then x cannot equal 4. In terms of hypothesis conclusion, this is still the part, oh, excuse me, wrong color. This is still the hypothesis, so we're still assuming true. And this guy's still the conclusion, which we're going to test to prove. So it's kind of weird in the sense that it's the if and then part actually dictate what is going to be soon to be true, even though the parts are moving around, which is important to note here that no matter what, and I'll highlight this part in say orange. This part right here is still the part I'm always assuming to be true, no matter what. And the second part, the part that comes after the then, which I'm going to highlight in green, that is always a part that I have to test or prove. Um, I guess I kind of wrote that wrong. That is a conclusion, but we're going to actually have to test to prove this. Okay. So in short, there is going to be some notation for this. Let me break this really fast. Okay, so there's going to be some nice notation for this. So this is my original. We can write this as if P then Q. And again, the P and Q stand for hypothesis and conclusion. So it's always going to be if hypothesis then conclusion. So with that being said, the inverse of a statement would be not P implies not Q. And the not symbol is nothing more than just like this upside down right angle symbol. The converse is a switching of those two. So it's going to be if Q then P. And the contrapositive is a combination of the inverse and the converse. So if not Q, that implies then not P. Oh, that's not a P. There it is. And that arrow takes the place of that if-then structure. So I do want to note, and even though these have been switched around, if I look just at, say, the inverse, this is still the conclusion, and this is still the hypothesis. But for the converse, even though, again, they have been switched around, this guy still counts as a hypothesis of my statement, and this guy is still the conclusion of my statement. Even though it's been switched around from the original, it's still always hypothesis then conclusion, hypothesis then conclusion. Same thing here, that's my conclusion, even though it has been switched, and that is my hypothesis. Well, again, we always assume the hypothesis to be true, always, always, always. And then we have to test the conclusion, and the conclusion always comes second, and that's because, and one way you can tell, is because of this arrow. That arrow is a big indicator. It always says, we'll start with P and then move towards Q. Start with not P and then move towards not Q. Start with Q and then move towards not P. Start with not Q, move towards not P. So guys, those are the notes. So same as always, let's get that summary in. And here's my standard kind of instruction for the summary. What we're going to do is choose 3 to 5 words or phrases in your notes and highlight them. And then you're going to use highlighted words to construct a summary. Okay. And just like always, if you want to, post it at Modo for bonus points, you can. Okay, so post it under this video as a response. That way other people can see it. Maybe it can help them out too. All right, so one last thing, in about 10 seconds, I'm going to fill in the questions I think are necessary. Again, I encourage you to actually pause the video right now and write in those questions yourself. I mean, that's a good way to test whether or not you actually understand what's going on. If you can look at these notes and say, well, this is a question those notes are answering, you're in good shape, all right? So pause the video now, try it on your own, and then unpause it and see what I wrote too, right? So pause. So the question I would say for this one would be, it's definitely about vocabulary. So it's kind of like your very standard, what are like the important terms? For conditional statements. So in this one, we're talking about just what a conditional statement is. So that's got to be the question, right? So what is a conditional statement? And then I also say, what's its structure? All right, and so in this next section, we're talking about the variations of a conditional statement. So that's got to be the question. What are the variations in, oh, in, no, of? Question mark. And then in this last section, we're talking about the notation or shortcut notation. So that's got to be the question. What is a shortcut notation for conditional statements? Okay. So thank you guys. Don't forget to post your summaries on Edmodo. Thanks.